ஸ்டார்ட் பண்ணிட்டேன்.
சரி,
இதை
நான் இது பண்ணிக்கலாமா? Good afternoon everyone. Today I am going to handle the topic of problems on three-phase induction motor. So first of all, what is an induction motor? Here the motor runs by the principle of induction. That's why it is called induction motor. Based on that, here the rotor always run at a speed less than that of synchronous speed. So here we can discuss some problems. So the first problem is a 746 kilowatt 3-phase 50 Hz 16 pole induction motor has a rotor impedance of 0.02 plus j 0.15 ohm at standstill. Full load torque is obtained at 360 rpm. Calculate the ratio of maximum to full load torque, the speed at maximum torque, the rotor resistance to be added to get maximum starting torque, the ratio of maximum torque to starting torque. So these are all the four subdivisions we have to find out. First we have to write the given data. So the number of poles is 16 and frequency is 50 Hz. Full load speed is given as 360 rpm and R2 is given as 0.02 ohms. X2 is given as 0.15 ohms. Let us first calculate synchronous speed. So what is the formula for synchronous speed? 120 F by P. So 120 into 50 divided by the number of poles, here it is given as 16. So we can calculate the synchronous speed. So Ns, which is given as 375 rpm. So we are getting the synchronous speed as 375 rpm. Then we have to calculate first division, the ratio of maximum to full load torque. So in order to calculate the full load torque, we should know about the full load slip. So we know already what is a slip. It is nothing but it is the difference between synchronous speed and actual speed expressed as percentage of synchronous speed. So we have calculated the synchronous speed and we are getting it as 375 rpm. Now we have to know about full load slip, that is SFL. Okay, so SFL is nothing but we can calculate by Ns minus NFL divided by Ns, where Ns is synchronous speed and NFL is full load speed divided by synchronous speed. So synchronous speed is given as 375 rpm minus full load speed is given as 360 divided by 375. So the full load slip which we are getting is 0.04. So it is nothing but 4%. 4%. So we are getting it as full load slip of 0.04. So now in the first division we have to calculate the ratio of maximum to full load torque. So the formula for maximum to full load torque is given by Sm square plus SFL square divided by 2Sm into SFL. For that we should know what is the maximum slip. So maximum slip is nothing but it is the slip at which the maximum torque which we are attaining. So here Sm equal to R2 by X2. Usually the slip varies from 0 to 1. So we know what is R2 and what is X2. So from that we can calculate what is Sm. So here R2 is given as 0.02 ohms and X2 is given as 0.15 ohms. So substituting we can calculate Sm. So you substitute here. So R2 is given as 0.02 divided by 0.15. So you are getting Sm as 0.133. It goes on. So we have calculated full load slip as well as maximum slip. With this we can calculate the ratio of maximum torque to full load torque. So here you substitute Sm square, that is 0.1333 square plus SFL square, it is 0.04 square divided by 2 into Sm is 0.1333 into SFL is 0.04. So on substituting it, we will be getting it as 1.817. So this is the ratio of maximum torque to full load torque. So we have calculated, that is the first division. Then second division, the speed at maximum torque. So we have to calculate Nm. Nm is nothing but the formula for Nm is Ns into 1 minus Sm, where Ns is synchronous speed and Sm is the maximum slip. So Ns we have already calculated, it is 375 RPM, and Sm also we have calculated, maximum slip is 0.133. Substituting, we can calculate the maximum speed. Nm equal to Ns is 375 into 1 minus Sm is 0.1333. So from that we can calculate Nm equal to 325 RPM. So this is Nm. So second division also we have completed. So the speed at maximum torque. So the formula is Nm equal to Ns into 1 minus Sm. Substituting we are getting. And the third division is the rotor resistance to be added to get maximum starting torque. So to get maximum starting torque, we have R2 should be equal to X2. This is the condition to be satisfied to get maximum starting torque. So we have R2 in the problem, it is 0.02 ohms and X2 is given as 0.15 ohms. In order to get maximum starting torque, here that R2 should be equal to X2. So that what we have to do means X2 is 0.15. We have to find the difference between that two. So the difference will be 0.15 minus 0.02, which will be 0.13 ohms. So this is the resistance to be added, that is the rotor resistance to be added to get maximum starting torque, that is 0.13 ohms to be added to get maximum starting torque, because the reactance value is 0.15 ohm. So the difference we are calculating, and that resistance to be added to get maximum starting torque. And the fourth division is the ratio of maximum torque to starting torque. So we have to calculate the ratio of maximum torque to starting torque. So here the formula for maximum torque to starting torque, it is given by 1 plus Sm square divided by 2 Sm. So here 1 plus Sm squared we have to calculate, already we have calculated. So 0.1333 square by 2 into 0.1333. So we will be getting it as 3.8176. So this is the maximum to starting torque. So these are all the 4 divisions that we have solved step by step. Hope you will be understanding this problem. Let's move on to the next problem. So the next problem is an 18.65 kilowatt 4 pole 50 hertz 3 phase induction motor has friction and windage loss of 2.5% of output. Full load slip is 4%. Find for full load, we have to calculate rotor copper loss, rotor input, shaft torque and the gross electromagnetic torque. So now we are moving to the second problem. An 18.65 kilowatt 4 pole 50 hertz 3 phase induction motor has friction and windage loss of 2.5% of output. So full load slip is 4%. Find for full load rotor copper loss, rotor input, shaft torque, the gross electromagnetic torque. Let's write the given data. So the output power is in terms of watts we are writing. So it is 18.65 into 10 power 3 and number of poles is 4. Frequency is 50 hertz. Slip is 4%. So it is 0.04. Friction and windage loss. So the loss is due to the rotation of the moving parts. That is nothing but the friction loss, and due to air we are getting windage loss. So it is 2.5% of output. So we can write it as 2.5 by 100 into the output is given by 18.65 into 10 power 3. So if you calculate, you will be getting the friction and windage loss. That will be, so we can calculate the PM, that is gross mechanical power developed, which is equal to output power, that is 18.65 into 10 power 3 plus the mechanical losses. It is nothing but 2.5 by 100 into 18.65 into 10 power 3. So if you calculate, you will be getting it as 19116.25 kilowatt. So this is the gross mechanical power developed that we have calculated, and we have to calculate the rotor copper loss. That is our first division. So PC we have to calculate. So PC by PM, we have the formula. So PC by PM equal to S by 1 minus S. So we have find out PM. So from that we can calculate PC equal to PM into S by 1 minus S. So PM is 19116.25 into slip is given by 0.04 divided by 1 minus 0.04. So if you substitute, you can find the rotor copper loss. So you will be getting it as 796.5 kilowatt. So this is the rotor copper loss. So first we have to find out the gross mechanical power developed. It is nothing but the output power plus mechanical loss. So the mechanical loss is nothing but it is due to the friction as well as air. So after calculating this, we are getting PM is 19,116.25 kilowatt. Then we have to find the rotor copper loss. So PC we have to calculate. We know already PM, slip also we know. So you can find out PC equal to PM into S by 1 minus S. So we have calculated the rotor copper loss. Now we have to calculate rotor input. So second one is rotor input. So rotor input, which is equal to, we have to sum that PC, rotor copper loss plus mechanical power developed. So PC plus PM, that will give you rotor input. So PM is 19116.25 plus PC is 796.5. So the rotor input we can find out. So if you sum these two, you will be getting 19912 kilowatt. So this is the second division. And the third division, we have to calculate shaft torque. So shaft torque we have to calculate. So T shaft, which is equal to P out divided by omega. So omega is nothing but 2 pi n by 60. So output power is given. So 18.65 into 10 power 3 divided by 2 pi into n divided by 60. So this one we have to calculate n. Before that we should know what is ns, synchronous speed. So ns equal to 120 f by p. So 120 into 50 divided by 4. So it is 1500 rpm. So ns we have calculated. So n, the actual speed of the rotor, that is nothing but ns into 1 minus s. So ns is 1500 into 1 minus slip is given as 4, that is 0.04. So we will find out n. So the actual speed we can find out here. Okay. So after substituting this value here, you can find out T shaft. So T shaft equal to 18.65 into 10 power 3 divided by 2 pi into n. Instead of n you can substitute ns into 1 minus s. So 1500 into 1 minus 0.04, and this will go into numerator 60. So you will find out the shaft torque. So T shaft, it will be 123.677 Newton meter. So this is the shaft torque. So shaft torque is nothing but it is the ratio of output power to angular speed. So output power is given. We have to find out omega 2 pi n by 60. So we have to find what is the actual speed of the motor. So that we can calculate from synchronous speed. So first we have calculated the synchronous speed, and then we are substituting in the formula n equal to ns into 1 minus s. We are finding the actual speed. Then we are substituting in the shaft torque. So you will be getting shaft torque equal to 123.677 Newton meter. And then fourth division, the gross electromagnetic torque, it is nothing but T suffix G. So the fourth division is gross electromagnetic torque, it is nothing but Pm by omega. So Pm we have already find out, it is 19116.25 into 10 power 3 divided by omega. So omega is nothing but 2 pi n by 60. So here n you will be getting it as 1440 rpm. So 2 pi into 1440 into 60, that is nothing but the gross torque. So after substituting we will be getting the gross torque. So the gross torque is given by 125.7685 Newton meters. So it is the gross torque value. So in the second problem we have calculated the 4 divisions. First one we have completed rotor copper loss, then rotor input, then shaft torque, and then the gross electromagnetic torque. So any doubts in this?